Welcome, everyone. Thank you again so much for joining us today. My name is Laura Minier, and I am a Senior Program Associate with the Inclusive STEM Ecosystems for Equity and Diversity Program, or ISEED, at the American Association for the Advancement of Science. And I work on our AAAS-IUSE Initiative, which is hosting today's workshop, Inclusive STEM Environments Inside and Outside the Classroom. And we are excited to hear from our presenters today, Dr. Mark Griep and Dr. Annie Wofford. A few housekeeping notes before we get started. This presentation is being recorded, and the recording and slides will be made available in the coming weeks on our website at AAAS-IUSE.org. You can also view the slides today at the link that's going to be provided in the chat. You will receive an email when the recording is posted. Please note that we will transition to breakout rooms to allow for further engagement, and these breakout rooms will not be recorded. We also have closed captioning for this workshop, and you can download and view the full transcript by clicking the CC button at the bottom of your screen. So before we turn it over to our presenters, I want to provide a little background about AAAS and our IUSE initiative. So AAAS, the American Association for the Advancement of Science, was founded in 1848 and is an international nonprofit organization dedicated to advancing science, engineering, and innovation to benefit all people, with the specific goals of strengthening and diversifying the science and technology workforce and fostering education in science and technology for everyone. With more than 120,000 individual members in more than 91 countries, AAAS is the world's largest multidisciplinary science society and a leading publisher of cutting-edge research through the Science family of journals. You can learn more about AAAS on the website AAAS.org. For those of you who are new to the AAAS-IUSE, this initiative seeks to support faculty, students, and the greater undergraduate STEM education community by disseminating research and knowledge about STEM teaching, learning, equity, and institutional transformation. We invite you to learn more about the AAAS-IUSE initiative on our website, and we hope that you will join our community as future contributors. You can also follow us on Twitter at IUSE Program and LinkedIn to stay up to date on our latest events, vlogs, or to share what you've learned at today's workshop. So now, without further ado, I'd like to turn it over to Dr. Mark Griep. Mark is a professor of chemistry at the University of Nebraska-Lincoln. So Mark, over to you.
Okay, welcome everyone. I'm going to share my slideshow. So I'm going to talk about the sharing cycle of science learning, which is a description of a project that we started in 2013 with Nebraska's 2 tribal colleges, and I'm at the research university, which is 3 hours away from the tribal colleges, and I've got 2 facilitators going to help me. Bev DeVore Wedding was a major player in this project as well. And so the description in the call for signing up for this thing said we were going to do, I'm going to tell you about the ethnoscience approach to introductory science courses. And I'm going to do that, but it's bigger than that. And so it is, how can you indigenize any course? How can you make your course more welcoming in general? And so we've already done the introductions on the chat, so I'm not going to do that. But my sense was there aren't that many chemists here. It's not necessarily necessary for you to be a chemist to understand what I'm going to tell you. So let me talk about the NSF project that funded this, how we argued and were successful at getting it, and it worked. And so the focus of the project was looking for interconnectedness between all of the topics. Then we applied that to the chemistry lab experiences. And then I'm going to just bring out one minor part that turned out to be important, giving gratitude for the materials that we use. And so the argument we made in the proposal was that American Indian students are underrepresented in all STEM fields by almost 50%. They are the most underrepresented. And yet, the largest growth in jobs has been science and engineering related. There was a local need. Nebraska Indian Community College had not offered a chemistry course for 5 years. And this is what actually precipitated this collaboration. They had an external review, and it was discovered they hadn't taught chemistry, and yet chemistry is a requirement for their Indigenous science degree. They came down to the University of Nebraska-Lincoln looking for someone who could help them create an engaging chemistry course. And so they found me. It ended up being this proposal. And since there was this incredible local need, we went for it. And then Little Priest Tribal College is the other tribal college in Nebraska. They consistently offered it, but with low enrollment. So they wanted to join this too. We settled on a very simple goal: sustainable chemistry laboratory experiences where the enrollment is a consistent 6 students. So both tribal colleges consider 6 students to be enough to pay for the instructor. And sustainable just means, okay, this grant's going to end. Once this is over and the money's not flowing in, we want this thing to continue going forward. Now, 6 does not sound like a very big number, but I'm going to just show you that's a huge number. And our hypothesis. So how are we going to do that? American Indian students will be more inclined to engage in persistent chemical education when lessons and laboratory activities are framed within the context of community relevant events because of the students' strong sense of kinship and place. We didn't actually use the word ethnoscience or indigenizing in the beginning part of the proposal. That's what we ended up doing. So we had to, of course, do evaluation, and we were really interested in the student attitudes toward all of this material and whether they found the things we did engaging. But it was more than that. We wanted to make sure that the faculty and administrators were on board and that everybody knew at all moments what we were trying to do, and that, again, they thought we were going in the right direction because this is a community project. So the 3, we were funded. The 3 universities, institutions were Little Priest Tribal College, Nebraska Indian Community College, and University of Nebraska-Lincoln. And there are people associated with each one of those. The way that it worked out is that Janice Woodard taught the lecture, and she video teleconferenced it to Nebraska Indian Community College. Hank Miller is a biology professor, but he's also the chair of the science and math department at Nebraska Indian, and he was very much responsible for making students aware of this chemistry course and getting them enrolled. Bev DeVore-Wedding was getting her PhD in the Teachers College here at University of Nebraska, and I was just very lucky that she joined the team. She was, and so she worked for me while she was doing her PhD thesis working with someone else, but I paid her, and she was the intermediary between UNL and the 2 tribal colleges, and she led the laboratory. And this is a key component. She was there day to day, week to week, once a week, to get the feedback. And when she graduated with her PhD, she stayed on as my postdoc. So let me tell you about tribal colleges, because this is a topic that a lot of people don't know. I did not know anything about tribal colleges before I started this project. In 2016, there were 38 tribal colleges, and the little red dots show you where they're located, including these 2 green ones, which are in Nebraska. Tribal colleges, all but 2 of them, were founded by tribal councils. Tribal councils are the governing body of reservations. Reservations are sovereign nations, and every sovereign nation needs to be governed, and it was the US government that required every reservation to have a tribal council. It's not necessarily the way that the Indians themselves would have governed themselves, but it's a legal requirement. And so it was in the 1970s that a lot of the tribal colleges were founded, and they had the 2 missions: a normal community college mission of economic development, but then a tribal mission to preserve the history, the language, and the culture. And so knowing that, we wanted to make sure both of those features were incorporated in our course of full knowledge of what it is to be a contemporary Indian living on a reservation and managing their affairs. And so I hit upon this idea that we would connect everything to tribal sovereignty. What does the tribal council need to consider to maintain and enhance their sovereignty? Also on here are the enrollments. And so now you're getting a sense that with these low enrollments in the Nebraska tribal colleges, a sustainable number of 6 students enrolling in chemistry, that is a hard thing to do. We're envious of Sinte Galeska in South Dakota with their absolutely enormous enrollment, full-time students. And they are often pointed to as being a very good example of how tribal colleges, they all want to run like this. But each tribal college is different because they're serving different tribes and they all have different needs. And again, there's just tons of varieties here. There are even smaller tribal colleges than the ones in Nebraska. United Tribes Technical College in North Dakota, I believe, is 5 tribes that came together to join this college. Also shown on here is the outline of the Great Plains. So the extent of the Great Plains covers the central portion of the United States. And I think it's 2/3 of the tribal colleges are in the Great Plains. And there's a lot of similarity in the needs and interests of the tribes in the upper Great Plains. And so we thought about a lot about that too. So what we said was we would do 4 different things. We would identify a list of topics important to the community. And this was going to be created by our advisory board. And so here is a painting that I commissioned from Lori Hausman Whitehawk, who has 2 of the, her heritage includes 2 of the tribes that we were serving in this project. And so in this sector of the cycle, this is supposed to be the advisory board. And these are people from the community who are either teaching at the school, they're on the water board, they're on the environmental protection board, or they're at the tribal college. And then we had people who are nationally visible. 2 people who are facilitators, who are both Indians, very prominent academically, and they were key at getting this to work. Because Judy Gayashkabash, who is the director of the Nebraska Commission on Indian Affairs, she also joined our group, and she is a state-funded person to ensure that the Nebraska state government interacts with the tribal council in the true sovereign nation to sovereign nation manner. And so she was key at getting people to cooperate from the different tribes together on this project. The next thing we would do after we had these topics, and I'll show you those topics, was make connections between those topics and any science discipline. We were talking about chemistry. This objective actually changed a bit, and I'll tell you about that. Then we're going to create and offer a 2-semester chemistry sequence at Nebraska Indian, disseminate it to Little Priest. That also changed. Little Priest wanted in right from the beginning, and we cooperated right from the beginning. And the dissemination actually is more, right? So we did locally and regionally. And so once we developed our lab manual, we disseminated it to all the other tribal colleges that tried to get them to adopt it. So at our very first advisory board meeting, we asked the advisory board to come up with the list of community topics that enhance tribal sovereignty. And so we called them community topics, but Shelley Valdez, one of my co-facilitators, said, well, you know, the tribal worldview is holistic. Everything is connected to everything else. And she said, science also acknowledges that everything is connected to everything else. You know, we quantify how strongly, but they are connected. So she drew this orb. I actually have an oval here, but this is the sun. And then when somebody called out something that was important for the tribal council to consider, factor of disease, she'd give it a ray. And then if somebody wanted to do some nuance on here, there's a subray. So we got renewable energy, community health, ownership and stewardship of the lands, water resources. So as soon as somebody said water, I knew we could do all kinds of chemistry. And of course, everybody's interested in water. And the Missouri River tribes, which is what we're dealing with, are very interested in water. And so a lot of discussion about water. Air quality, climate change, natural resources, animal habitat, oral histories, economic development. So these are the major topics. that I then put in tabular form so that I could look at them and think about them. And so here's one of my points. So if a tribal council needs to consider all these factors, so anybody does, right? I think everybody's interested in renewable energy, or at least they should be. Everybody's interested in community health. These are universal topics, maybe not medicinal plants, but air quality, climate change, natural resources. We should consider how all of these things are connected. Now, then you get into the specifics, the personalization of it. What does it mean to me? And that's really how the direction we ended up going in, is making it very personal. Now, the advisory board met once a year after we went through a whole cycle and talked about it and stuff. And they, even after we thought we had done really a great job at indigenizing all of the experiments, they wanted us to do more. They wanted us to hire native faculty and teaching assistants. Now that is super hard. Now, we never even proposed to do that. We kept trying to figure out how to do that. That is not a problem that I've been able to solve, and I'm continuing to think about that. So as the project developed, and again, Bev DeVore-Wedding is the one who taught the labs. Over the years, the things that the students identified as being connected to particular chemistry lab experiments had to do with health, the medicinal plants, water, the soil, discussion about oral histories, and food sovereignty. So let me just show you what one of these experiments looks like. The second experiment, a very traditional one in all chemistry laboratory experiments, is density, because you get to learn how a balance works, and you get to learn how to measure the volume of an irregular shape. So the first part, very classical. What do we need to do? What do you need to know? Well, we're trying to measure density here, right? We need the mass and the volume. And why is that important? Why should we measure density? So then we come to the section 3, the community connection. So this is again how we ended up doing this. In the lab, students would be, you'd have that moment before you even start, where perhaps you review the community topics, probably more earlier in the semester, not so much later in the semester, and have the student describe how this is important to the community. And food, you know, you can make all kinds of connections. So then, classical thing again, safety, here's all the stuff. And then the indigenization part is the selection of materials in one way. And here for the samples on what we're going to measure the density of, it's corn, beans, and squash. Now, if you are an American Indian, you are more than likely to know that that's the Three Sisters agricultural system, but it doesn't say that here. And so we also knew that typically the person teaching these classes at tribal colleges is not an Indian and may be temporary. In fact, we found out most of them are temporary. So we have a teacher's manual that talks about the Three Sisters agricultural system to just make a little conversation about these materials. And then something we added fairly late in the process was a thankfulness statement. We're thankful for the bounty of food that we're able to use the corn, beans, and squash seeds in this lab. And so again, if everything's connected, then, and you're going to sacrifice something, you need to be thankful there's enough that you can do that. So these are all of the experiments that we came up with, and I definitely don't have time to walk you through all of these. I just told you about density. Let me tell you about one other one, plant pigments. Definitely a fun one. So the Missouri River tribes, there was this book published in 1912. Guy went out and interviewed all the tribes, tried to find out what to use all the plants for, and you can read this book and find out which plants gave which pigments. And so you could do things like, you know, the state symbol. And here's Colorado, Bev's from Colorado. And then I created a an outreach event. So you could adapt a lot of these labs to being outreach. And here a student is painting the electronic structure of neon. So why neon? Well, neon and Nebraska have the same symbol, Ne. Nebraska is the Oto Indian word for the Platte River. that runs through the middle of the state. So we have an Indian name for our state. Neon is the 10th element, and University of Nebraska-Lincoln is a member of the Big Ten. So all I have to do is draw this where the 10 electrons are around the nucleus. And the students love doing this. So in case you want to indigenize any course, you can do something by making a connection to the name of your state for 28 states. And here is the instructor manual. And again, it tells you how to prepare all the materials, how to set it up ahead of time, possible answers, and all kinds of fun stuff. So here again is the gratitude statement. And when we go to the breakout rooms, what I'm hoping that you will discuss is, how would you justify including a relevance discussion in your science or engineering labs? And then how much weight would you put on that? And then this giving thanks thing. And so I've taught the chemistry course for non-science majors at Nebraska for over 15 years now. And I'm going to include this fairly soon if I have time. I'll get it done before the end of the semester. But we're going to put this relevance discussion in all of our labs. And I'm not sure what we're going to connect it to, but I probably will choose the list that we had. And I'm still thinking about this prayer, whether to put in the prayer. So I would be interested in your feedback on whether you would do this. And so with that, I am done and we can move on.
Great. Thank you so much, Mark. We really appreciate you being here today and sharing your work. We will be having time for breakout room discussions like Mark mentioned, so we look forward to continue to learn from you then. Now I'm going to turn it over to our next speaker, Dr. Annie Wofford, who is a current postdoctoral scholar at Northern Arizona University. Annie, over to you.
Thank you so much, Lauren, and thank you for your excellent presentation, Mark. It's delightful to be here with all of you today. I'm going to go ahead and share my presentation. All right, so to get started, to briefly introduce myself, hello everyone, thank you for being here today. My name is Dr. Annie Wofford. My pronouns are she, her, hers, and as Lauren mentioned, I am a postdoctoral scholar at Northern Arizona University in educational leadership, where I do a lot of research about equity in STEM-related spaces, particularly as it relates to changing the structures and the policies of how we think about different spaces in STEM environments for college students who have been systemically minoritized in these spaces. So today I'm going to be sharing a little bit of research with you that I've been collaboratively conducting with my colleagues Katie Smith and Brianne Branch. Dr. Katie Smith is here with me today, so that's very exciting. And our presentation today is titled, "There's a Much Bigger Picture: How STEM Student Organizations Can Catalyze Inclusivity for Undergraduate Women in Engineering." All right, so I did want to provide a little bit of context for where I am situated as well. So in the context of living in Southern California, I want to provide gratitude and acknowledge that I learn and celebrate the work of the Indigenous peoples of the land that I settle in my research and teaching so that future generations can thrive. I am currently located on the lands of the Kumeyaay peoples in what is now known as San Diego. I conducted some of this research when I was still a PhD student at UCLA, which is located on the lands of the Tongva peoples. And I wish to honor the legacies of the original peoples of this land, past, present, and future. All right, so as we get going in this workshop, I wanted to talk a little bit about the objectives to give you an overview of what we'll be discussing today. The objectives of this workshop are to understand the discriminatory spaces that women navigate in engineering specifically. And also, we will be describing how student organizations can be spaces of resistance for women in engineering. And then we will engage in some discussions later on that incorporate aspects of reflection and discussion about commitments to disrupt inequitable policies or practices in your local STEM environments, knowing that many of us hold very different roles. To do so, we'll go through the background and context of an empirical study that my colleagues and I have been working on. And we'll go through some examples from that study and share some quotes from participants that we have been engaging with. We do have a little bit of an exercise for all the attendees today included in a Google Jamboard. And then we will go into the discussion and Q&A session. And as I briefly mentioned as we started today, I do want to acknowledge and thank the awesome research team that I've had the privilege of working with in this research. Dr. Katie Smith, who's here today, and Dr. Brienne Branch. Just to give a bit of a funny story about how our world all works together in higher education. Brienne and I actually met when we were both working at the University of Missouri, Kansas City, and then both found ourselves out in Southern California for different reasons. And so you just never know who's going to be in these spaces that you might come across again. We also would like to thank ACPA Foundation, which is a student affairs organization, for their funding support of this empirical study. Katie and I received a small grant to fund and incentivize the participants of our study, and we're thankful for their beliefs that this work deserves that funding and is important to sustaining women in engineering environments. So the research study that we have been conducting is situated by a couple of prominent problems in engineering. So to give a little bit of context here, we care really deeply about increasing the diversity and equity for women in engineering environments. It is important to recognize that the disparities that women incur in their engineering environments, for example, cannot be solved by compositional diversity alone, however. And so you'll see here that women now represent 57% of bachelor's degree recipients across all fields of study. However, in engineering, this remains starkly low at 22%. And as I mentioned, this representation is not the only issue that we seek to address in our study and in our work, but it is important because these exclusionary environments and the lack of representation in these environments has been consistently associated with oppressive structures that threaten women's access and success in college engineering. And so importantly, it's also very key for us to remember that women's experiences with discrimination in engineering environments are shaped by more than their gender identity. Racism, classism, ableism, sexual oppression, like all of these systems of oppression intersect with sexism and the gendered nature and intersecting nature of oppression in engineering. And while the intersectionality aspect was not a key focus of our specific study here that I'll describe today, it is incredibly important for us to contextualize women's lived experiences in our study through a lens that acknowledges the multiple identities that they hold and the complexities that come along with that. And in our contextualization for this study, we also make the case that because women are outnumbered in many settings, they may face challenges in cultivating what is called an engineering identity. And engineering identity has been well established by a robust body of literature in its importance in cultivating a sense of kind of agency and belonging and making sure that students feel like they are becoming engineers that can successfully contribute to the discipline and the industry. The qualitative study that we engaged in was guided by an exploratory question here, namely, how do undergraduate women make meaning of their engineering identity within STEM student organizations? And we purposefully left this pretty broad in terms of the way that we were structuring this research question and what we were interested in, as that aligned with the ways that we wanted to prioritize hearing women's voices in terms of what they were describing about their STEM student organizations, and also with our perspectives that as feminists, we can't ascribe certain concepts that they will feel about these organizations. And to conduct this study, we relied heavily on the theorization of Carloni and Johnson, who came up in 2007 with an analytic model of science identity. And we use science identity to theoretically explore the phenomenon of engineering identity in STEM student organizations. So in their study, Carloni and Johnson established triadic notions of science identity, first describing competence as more of a knowledge-based notion of science identity, where oneself would understand that they get the scientific concepts. They feel like they have a mastery of these concepts. There's also an element of performance, which usually is described in terms of the local environment that students are in, where they are exhibiting social ways of mastering scientific practices. So for example, in a lab environment, this would be a student showing their peer perhaps that they can do a certain type of experiment. And then finally, recognition is the third aspect, and one that Carloni and Johnson focus heavily on in their work. This relates specifically to the ways that individuals both identify themselves as engineers in our case, and also are identified from other perspectives as engineers or a scientific person. So this is the component that we truly focused on in our paper, as we were interested in understanding how interactions that students were having in these STEM student organizations might facilitate their own recognition of themselves as an engineer, and their recognition from other folks as an engineer that could be trusted and valued as a member of the community. Our methodology for this paper and for our larger project is driven by feminist phenomenology. And I briefly mentioned this earlier, but a focus on feminist phenomenology in a qualitative sense here really helps our study focus on how social reality and individual perceptions and women's meaning making as participants in our study talking about their organizations are affected by their gender. And sometimes this was in very implicit ways, sometimes it was more explicit about participants talking about the different experiences that men might have or gender non-binary students might have, but that how their experience as a woman did differ from those experiences. We draw the data for this paper from a larger study about women's internships in engineering. So we'll get some forthcoming work out about that shortly. But this larger study about women's engineering internships drew data from one institution that's a research institution on the West Coast. We conducted recruitment in spring 2021, and we recruited through STEM student organizations, which is a unique attribute of this study. So there's a number of studies that exist in the higher education literature and in the STEM education literature that talk about student organizations, but frequently just by way of that being something that a student mentions kind of offhand. And so we chose to purposefully use student organizations as a way to really get at some of these clusters that women were affiliated with. And in the data collection process, we had participants engage in both a written timeline, talking about their interest in engineering, their college experiences so far, and also they conducted one interview that was pertinent to this particular study. We then conducted some additional data collection about the internship process, but I won't get into that today. So specifically, we did use criterion and snowball sampling at this institution, and also utilized the Career Center for additional recruitment techniques if we were looking to reach out to different student bases. Just to give you a little bit of a sense of who the participants are in the study that I'll be talking about here, we had 24 participants, all undergraduate women in engineering. You can see a breakdown of their racial and ethnic identities here, which are grouped for anonymity, but we did collect this data via an open text response in our intake survey for the study that allowed women to authentically describe their race or ethnicity in the way that felt most genuine to them. Additionally, we contextualize our findings with information about the types of student organizations that women were involved in. Again, these are grouped for anonymity purposes to maintain anonymity of the institution and the participants. But you can see here that content-related organizations, for example, organizations that centered on a specific component of engineering, identity-based organizations that might have been specifically established for, say, women in engineering or another identity group, Or there were also some organizations that were more humanitarian or leadership focused, which I found really interesting. So the humanitarian focused organizations had an explicit focus on giving back to the community in ways that others didn't, and perhaps engaged the community in unique ways. And also leadership organizations were specifically different as well, providing different university type of engagement. So to give you a little bit of an overview of the findings here, through 3 themes, our findings speak to several ways that women were considered as engineers and viewed themselves as engineers, both by salient others in the engineering community and in reflecting on their own identity development. So the first theme that I'll talk about today is seeing oneself as an engineer, and we use a quote to describe this from a participant who said, "I have a place here in engineering," when talking about her student organization. We also uniquely talk about possibility models in the peers in these student organizations and what it meant for them to have a critical mass in these student organizations. In a quote that describes this, "She really broke our own stereotypes," which I will describe a little bit more in depth here in a moment when talking about the possibilities that women were able to see modeled through their peers. And then finally, we'll talk a little bit about being recognized as an engineer. These student organizations have some legitimacy on campus and do provide some sort of networking opportunities. And one participant said, "They hired me immediately." So to get a little bit more in depth to these 3 themes that I'll talk about, the first theme does relate to how women saw themselves as engineers. And importantly, we talk about in our paper how these organizations established more community-driven and more inclusive environments for women than the curricular environments that they were a part of. And participants were frequently comparing their organizational experiences to disheartening or negative interactions that they had had in class. And for several women, these organizations are ultimately what retained them in the discipline and perhaps even at the institution. So here we talk about how women noticed organizations' actions to create inclusive opportunities, and their first impressions of these organizations had a lasting impact on how they were seeing themselves as engineers. So many participants sought out these organizations as one of the first things that they wanted to do on campus to help find a community. And it was really important then for them to have that community, especially when classes got a little bit rough or they were having some really negative interactions with their peers or professors in classes. We also talk in the paper about how participants revealed that they felt more welcomed and a lot more comfortable in their organizations than any other curricular environment, which turns out to be one of the key implications that we talk about from this paper, as well as we as a research team would be really passionate about seeing the community and affirming driven environments of these organizations being implemented in the broader engineering community. So here, through Grace's quote, who's an Asian woman who left electrical engineering and ultimately joined computer science, talks about the organization that she was a part of by saying, "I'm the only CS major on the board because I was electrical engineering and I'm not anymore. Even though I'm not in the same major, I like that this community is very supportive, that we are all women in STEM. We're all having the same problems and we're all going through the same struggle of finding internships and going through our classes, trying to determine what we want, and that has helped." Ultimately, just to summarize kind of Grace's takeaway there, she found that the organizational environment that she was a part of was more important than that of her major, which really spoke volumes to us when we were writing about this phenomenon and how organizations were a tool of retention. Getting into the discussion about possibility models and peers and a critical mass, this was really a unique feature of STEM student organization spaces when it comes to building community and also viewing peers in a different way than just as peers. They really were exemplifying what an engineer could be in many ways. So seeing these advanced peers be themselves in authentic ways prompted the women in our study to feel like they didn't really have to hide a part of who I was. They could be engineers in authentic ways that felt true to their own identities, gender and other identities that they held, and also exhibit kind of their competence and performance, to borrow from science identity, in ways that felt authentic to them. So we had actually 3 participants in this study speak about the same peer as a possibility model of agency and gender presentation in engineering, saying that, you know, this advanced peer, who also held a leadership role in the organization, tried to wear the polo of the company that she was interning for, and it didn't feel comfortable to her. And so she started wearing a bright pink suit because that felt more comfortable to her. And to the participants that we spoke to, that was really inspirational, and they admired that as a strategy to help maintain their own identity and their own sense of self in these engineering environments that typically otherwise would want them to conform or assimilate in a different way. And we also talk in our paper about how a critical mass of women in organizations, even those organizations that were not explicitly identity focused, helped participants be aware of how much easier it was to have their voice heard in an environment where women were the critical mass. And it almost seemed like this was the first time that they had felt this experience as well, talking to several of the participants, because they all knew that industry doesn't have great representation from women. They might not have the opportunity to have this sort of environment again. And they all felt very grateful to have built community. So here we share a quote from Alana, who spoke about the power of this communal approach to learning, who said, "Personally, all of the building I've done prior to college has been mostly independent. So it's really nice to actually be in a group and develop together and learn from each other, since we're all developing different features and we're all piecing that together. Overall, I think the collaborative environment within the communities I'm a part of has definitely contributed a lot." And this kind of shows the power of communal learning as well in a discipline like engineering that is typically framed as a very independent and kind of, individual learning environment. And then finally, our third theme of this study relates to the ways that other important people in the scientific community recognized women as emerging engineers. We found that STEM student organizations provided some sort of a space of legitimacy and social capital, providing women with avenues to engineering opportunities that they might not otherwise have had. So these organizations were providing access to professional networking opportunities, different career fairs that were smaller and more focused. And these were ultimately providing women with greater access to some of those opportunities. Additionally, because women were being recognized as emerging engineers by people in power, which is a quote that one of our participants shared, they were established in some sort of new light of legitimacy as an emerging engineer, which I think was really important for their confidence building as engineers in training as well. And then we also talk a little bit about how participants were more comfortable at the networking and professional events that were sponsored by these student organizations, rather than the larger institutional career fairs, which often felt overwhelming. And here we share a quote from Sydney, a white woman majoring in bioengineering, who said, "I think the most meaningful sources of recognition are people in power. A teacher or a mentor sees it in a bigger scope, more relative to others rather than just relative to yourself." And so here, Sydney was really making meaning of the ways that being recognized by someone with institutional power made a difference in how she was perceiving her own progress as an emerging engineer. All right, so we're going to take a minute here, not a very long time, but I would like to hopefully garner some engagement on this Google Jamboard that my colleague Katie is going to share in the chat. Now I want to take this as a moment of reflection. We'll be doing this via Jamboards, and if you've never used Jamboard, it's pretty simple. You just either add a sticky note or some plain text. And our hope is to reaffirm this as a safe space where you can share openly and vulnerably, but we also do recognize that there may be some power dynamics inherent in the position that you hold socially or professionally. And so we won't ask you to share your name or anything too specific in this reflection process. And we are also open to sharing with courage and accountability, prioritizing safety over comfort and learning over perfection. Now, to make sure that we provide anonymity in this process as well, I won't be like publicly saying any of the reflections that you share here, but my hope is that you keep this link open for our discussion time as well. So Katie is going to share that link if she hasn't already. I can't see the chat because I'm sharing, but the question is for you to take about 3 minutes here to reflect on any ways that you have witnessed or personally experienced gendered, racialized, or otherwise inequitable learning environments through your participation in higher education. And again, you can be broad or as specific as you would like to be, but we are going to maintain anonymity of all responses here. So I'll give you about 3 minutes. Thank you all so much for sharing your experiences that you have either experienced personally or those you have witnessed in the environments you've been a part of. My hope is that you continue to reflect on this as we wrap up our presentation today, and that this chat can be a resource for you as we enter the discussion phase as well. Just briefly, I wanted to pivot to sharing a little bit about how our team is envisioning implications for practice from this work. And we are very passionate about helping practitioners feel empowered to help student leaders craft inclusive recruitment policies and community building strategies for their organization. And it's also incredibly important for institutions to create opportunities for these countercultures of organizations to become the dominant cultures of engineering. So there needs to be better mechanisms of institutional training and accountability for faculty to draw perhaps from feminist perspectives on ethics of care as one starting point. We talk about this in our paper as one potential for incorporating more holistic and authentic practices in the classroom and helping faculty realize that people are human outside of being engineers. And that is one of the most important things that student organizations are offering women. And so if we can think about ways to incorporate the humanity of women and of other students in the classroom itself, we can create more affirming environments for engineering as a whole. So the takeaway from our study here is that there is great power in reflexively considering exclusionary norms in curricular STEM spaces, and it is crucial that faculty, staff, and policymakers use their power to change these broader norms. And once we get into the discussion here, we will ask you to think about ways that a component of a STEM program or policy or practice that you are a part of might be one that you can commit to evaluating for equity-minded change. And we ask you to reflect on how lessons from women's experiences in student organizations shared here can contribute to your evaluation process. So thank you very much for being here today.
Great. Thank you so much, Annie. And thank you so much for sharing your insights and your work on supporting women in engineering. We're excited to continue this discussion with both Annie and Mark in breakout rooms. So we're going to transition now into facilitated breakout rooms. Welcome back to the main session, everyone. Thank you for participating in the breakout rooms. I'm wondering if we can go around and get our speakers and facilitators to share a quick recap of what their group discussed. So I'll start with Mark.
Okay. We started talking about how my audience for my chemistry course were American Indians, and that perhaps what we had figured out here was most relevant for them, and it would be harder for Blacks and African Americans, people of color, or diverse populations to make this direct connection to a very small list of topics. And then it moved on to just in general, this idea of respecting where you're from and what the community is all about. And I'm going to leave it there.
Great, thank you so much for sharing. And I'll turn it over to your colleagues. Beverly, would you like to share?
Our majority of our discussion was on relevancy and how do you actually grade that? And we decided it should be, or we discussed that it would not be a major grading percentage. But one of the participants said that to make that connection, she actually told her students to watch the news the night before they came to class, because they were unaware of what was going on in the world and the connections. And experiential learning, how important that is in incorporating reflection, as well as having the students think about, why am I learning this and what did I really learn? We just the last 112 seconds brought up talking about the second question of giving thanks, and we did not come to a conclusion. They just took us away.
Yes, the countdown is very quick on Zoom, but thank you so much for sharing, Beverly. And I'll turn it over to your colleague, Jessica.
Okay, so we were able to kind of touch base on all the topics. So for the most part, our group was kind of agreed, like it's nice to have students try to think about, how can I relate this concept to my everyday life as much as possible, just to keep them engaged. As far as the grading part, different ideas were giving up, as in maybe have students work in discussion in lab with their peers to where they can communicate with one another and have a healthy debate in class, and also make that connection peers to peers, and then create that kind of connection they may not connect outside of the lab. And also, like, maybe not necessarily either give a rubric on what they're going to be graded if that's the case, or just give them a freedom of expressing themselves without necessarily be too harsh. We talk also about good versus bad answers, or like non-specific, like, oh, you relate to class and that's it, or like something more specific. But also maybe it's okay to say you don't know. So kind of like all kind of up in the air, those answers. And then for the thanks, my group was kind of like a 50-50, because it also kind of touched base a little bit of religions. And so depending on the institution you teach, is it okay? Is it not okay? But I think at least the part that was agreed, like, it would be a good idea, just to at least put things in perspective to where, hey, we're using these chemicals, it's $300 a gram. Wow, like it's a lot of money that the university give to us that some people might not be as fortunate, and maybe approaching more that way. So that was my session.
Great, sounds like a productive discussion. Switching gears, I'll turn it over to Annie to discuss what group talked about.
We had an excellent conversation that started out with people identifying future colleagues, so I loved that. Our discussion broadly talked about how we might be able to expand who's a part of these conversations to support women in student organizations and to make these cultures more affirming and communal in general, as we know that the people that self-select into these webinars and spaces are often those that are more committed. So how do we make sure that the voices who are not represented in these rooms are also getting this type of information and develop some sort of buy-in to making this a reality? We also talked about how to potentially incentivize students and reward students for stepping up and creating different student organizations where those community spaces are needed, as some sort of validation from folks in power, or reward from the university, maybe a scholarship or something, may speak wonders to how the institution is valuing these actions as well. And we were also thinking about the power of role modeling, right? That was something that came up in the paper that I talked about, and also is something that we recognize attention, where there is power in role modeling and having a role model that shares a lot of the similar identities as you. But we also know that those who are doing the disproportionate labor of role modeling are often Black women and other women of color who are already doing a lot more service at the university. So how do we grapple with the need for identity-focused mentors without overtaxing those who are already doing a lot of service? So it's a very productive conversation, though.
Yeah, it sounds like a great conversation. I'll turn it over to your colleague, Katie.
All right, so we had an opportunity to talk a little bit about science identity as a theory. especially some overlap between the three major principles of the theory: competence, performance, and recognition, in the way in which we are thinking about and defining each of those elements. We also talked about sense of belonging within STEM disciplines and how we can measure that in different ways, both qualitatively and quantitatively. And then a question came up about assigning groups within STEM classrooms and best practices about that, whether it's best to randomly assign groups or allow students to self-select, or be intentional about pairing people with other students who share their identities. And so folks within the group shared the practices that they use in terms of assigning groups and the ways in which we can create classroom spaces that are more friendly for students, especially those who hold marginalized identities within STEM fields, to feel like they belong and are comfortable within those spaces.
Awesome. Sounds like another productive conversation. So great. Thank you, everyone. And before we go, I just want to thank again our speakers, Dr. Griep and Dr. Wofford, and our facilitators and the rest of the AAAS-IUSE team, as well as all of you who are able to join us today. We are very pleased to be hosting 6 more workshops this year, so keep an eye out for those as well. We do have a post-event survey link, which we are posting in the chat and sending via email. And the survey will only take a few minutes. We really value your feedback as we look to improve these workshops in the future. Additionally, the recording will be available in the coming days on our website, and we will also email you when that is posted. Once again, thank you all for joining us. And as always, we look forward to engaging with and learning from you, the AAAS-IUSE community. Thanks, everyone.